This is problem 5-79. We have a boom supported by a ball and socket there. So the ball and socket's going to have a reaction in the X, a reaction in the Y, and a reaction in the Z. But it doesn't react any moments. We have a force here and a force here. Now those are both 30 degrees from the y-axis, the x-axis. This is the x-axis, so this is the x-axis here. So they are symmetric about that. They're going to have a component here and in the x direction, and they're going to have components here in the y direction. The components in the x direction are going to be equal and opposite at 5 cosine 30, which is 4.33. And they're going to have reactions in the y direction, which is 5 sine 30, which is 2.5. Now, it's offset by a cable that goes off here in the y direction. Now, if we consider this all one object, we don't need to worry about what the cable is doing here. We can just look at what the cable is doing here. I'm going to call that tension. Now, this one cable will offset these two because they are perfectly in the negative y direction. I wouldn't call this stable since there's nothing holding it in the x direction, but and so a smallest change in one of these forces and it's going to go. But as it's drawn, it's not moving. I would say it's not stable though. Okay, so our unknowns are t, ax, ay, az. So I'm going to start by summing the moments about the x-axis. If I sum the moment about the x-axis, ax, ay, z, ay, doesn't matter. Our only unknown is t. Sum the moments about the x equals. Now, because both of these are acting at that point, we can just add those together. So 2.5 plus 2.5 is 5. And they are acting at a height of 5. And they are going to cause rotation in the positive x. T is going to cause rotation in the negative x. And it has a distance there of 1.5. So solving for t equals 16.7 kilonewtons. Now I'm going to solve for the forces in the x direction. In the x direction, we have 4.3 and negative 4.3. And we have ax. And there's nothing else in the x direction, so ax equals 0. Okay, summing the forces in the y direction. So in the y direction, we have 2.5 and 2.5 in the negative. And we have ay. So ay equals 5. Now we'll sum the forces in the z direction. And in the z, we have t down. And we have az. And there's nothing else in the x direction. T is 16.7, so az is equal to 16.7. And that's it.